It's like a glitch.
Now we begin with the Fluent and we read the backward step problem which has already been created. The mesh is ready with us. I'm not reading the mesh. Read case. Okay, this is Fluent. Okay, I will go to the gambit zone where we saved our mesh, which is named as backstep.msh. Alright, it's reading the problem, right? Now grid check. I checked and there is no problem with the mesh. So it is alright, completely alright. Let's display the grid, which is like this. Okay, this is the problem. Backward facing stem and flow will be from this side, and there is a step here, it flows out, and here it is a volume in velocity in, and this is a pressure out. So this is how the mesh is, and why we have divided that area into, or the face into three different faces, is because we chosen three different mesh sizes. Let's go to the corner there and see that mesh size. You can see that this is fine mesh, little coarse, and this is much coarser. So mesh sizes are different. So we have successfully created mesh of different sizes in the same face, and we are going to solve this problem. So I close that, and after checking the mesh grid, you can also scale it. Okay, mesh grid was created in meters, and it is, you need not, I just keep it like that, but you can change the scale also. And you can also have something like zone separation. You can replace the zone and so on. You can smooth the mesh if required. When skewness is desirable skewness, and you can smooth the mesh and swap, smooth and swap, then that achieves a better skewness. Now again, grid check, it is fine. There are about 46,000 phase elements, 46,912. And now what I will do is, let's go to the model solver. It is okay. Define model. Multi-phase is not multi-phase one. So define energy. We don't solve energy equation. Define viscous. Yes, it's a laminar flow. We keep it like that. And rest of the things not required. Radiation, species, and other things not. Let's go to the material type, and there is a material which is air, which is already there. I keep it like that. Okay, close. Define operating conditions. It is ambient condition, no issue, and I'm not highlighting any changes there. And coming to boundary conditions, fluid is anyhow fixed, and default interior is nothing to do with that, and the pressure outlet is going to be zero gauge pressure. So keep it like that, zero gauge pressure. Velocity in, we need to give the velocity inlet, which is 0.02 kind of thing. Okay, when we calculate with the Reynolds number, we'll get the initial velocity. Walls, you need not worry, it's default material will be there. Okay, close. Now boundary conditions we fixed, and rest of the things we are not putting anything there. Now we need to initialize the problem with the velocity inlet, apply in it, and to monitor we need to have create the residual monitor plot. Okay, this is how the plot comes, and you can also set up the animation. So, but what I will do is iterate the problem. for solution. It's now solving. So the calculations done, it's not converged, but it is the number of iterations what we gave is completed. So I'm not going towards convergence of the problem. I will just display the contours for you, velocity contours. Okay, velocity magnitude. This is how the contours appears. Okay, velocity contours in the problem. If you have a closer look, this is how the velocity magnitude. Okay, and if you look at the stream function, it will be like this. Okay, and the pressure, if you plot, it will be like this. Pressure. Okay, you can also see filled manner, velocity and pressure. It appears like that, filled contours. Okay, and various other properties also you can compute and display. So you can also plot XY plot facility, but post processing, if you have something like tech plot or pair view, such softwares will give you much detailed information about the computational fluid dynamic problem. So what we have to do is solve here and study in post processing softwares for a better understanding about the physics of the problem. So we have not carried out the problem until convergence. We have decided the convergence criteria here. Solution in this setup, we need to give relaxation, under relaxation factors and problem like conditions to be adopted to solve, right? And you can also initialize with some, if required, some additional details, and you can also calculate and plot ISO values, like a pressure ISO values,